Hi, let's now try to look at partial derivatives. So we are given to say if v is equals to a multivariable function f of xy, where you have your x equals to r cos theta and y equals to r sin theta. We have to show that the second partial of v with respect to x plus the second partial of v with respect to y is equals to second partial of v with respect to r plus 1 over r by partial of v with respect to r plus 1 over r squared by second partial v with respect to theta there. Okay, so what it is here is that I have two sides of this. uh, Let me name this as my a, then I name this as my b. Okay, so now what it is here is that I have a choice to make. It's either I should show that a is equals to b or b is equals to a. Okay, so whichever method that you're going to use, as you're going to arrive at the same destination. And myself have chosen to use this one here. You can try out this one on your own if you like. It's still going to give you one and the same thing. Okay, so I've decided to pick the side that is appearing to be more complex, which is this one here, to show that it's equals to this one here that seems simplified. Okay, and this notation that we have here, which is our second partial v with respect to x, can also be written as, in this case, since I'm using v, this is going to be more like a v here with two subscripts of x, where you have your x here, another x. So um, this is not the same as vx. So this and this, in fact, if I put another x there, those are two different things. Okay, and again, this one here, which is the same as this one, can also be written as, I can say, partial of x multiplied by partial of v with respect to what? With respect to x. So what I have here and what I have here and what I have here is simply one and the same thing. So don't be confused if this is written in a very different way, maybe in a certain textbook or something. Okay, so let's get down to this. And before I continue, just in case you're new to the channel, consider subscribing and ring the notification bell so that each and every time we upload new content, you're going to get a notification. Okay, and in case of anything, you can comment down below, and we'll try to attend to you in the quickest time possible. Okay, so what it is here is that when I look at what I have this side, it's quite obvious. I'm looking for my partial. First of all, I'm looking for my partial of v with respect to r. I'm also looking for my partial of v with respect to what? With respect to theta. Then from these two, I'm going to get my second partial of v with respect to r, like that, and I'm also going to get um, my second partial of v with respect to theta, like that. So of course, first of all, you have to find the first partials before you go to the second partials. Okay, so let me first of all begin with partial of v with respect to r, which is the one that appears here, but of course it's the second, but I'll start with the first one as we are supposed to start. So our second part, I mean our first partial of v, or let me just say partial of v with respect to r, it will be nothing but partial of v with respect to x multiplied by partial of x with respect to r plus partial of v with respect to y multiplied by partial of y with respect to r, like that. So one thing that I have to find is that I observe that since my x is equals to r cos theta, and my y is equals to r sin theta, it's quite obvious that my partial of x with respect to r will be equals to cos theta. Why is it so? Because it's like you have two variables, you have your r and you have your theta. But since I'm differentiating with respect to r, because these are partials, I'm treating my theta as a constant. So when I differentiate r there, that's just going to be 1 multiplied by cos theta is still going to be cos theta. And the same applies to this one. You have your partial of y with respect to r is going to be equals to sine theta, because you're treating your theta as a constant. So this is going to end up to be partial of v with respect to r will be equals to partial of v with respect to x. What's your partial of x with respect to r? We have found cos what? We have found cos theta, plus this is going to be partial of v with respect to y, then partial of y with respect to r, we have found sine theta, like that. So now we can use what we have to get our second partial. So how we get it is like, for me to say my second partial of v with respect to r is going to be equals to, I'm still differentiating partially with respect to r, so it's going to be partial of r of what you have here. Okay, so I can just bring it down there like that. Then we can go ahead and do the differentiating there. Okay, so now this one is just going to be something like, if you observe, it's more like, here you have your A and you have your B, you have your C and you have your D. The point I'm trying to put across here is the fact that, this is it's more like it's a product of two functions, and you're supposed to use the product rule when differentiating there. Of course, keep in mind we're differentiating partially. So now what it is that if I keep this one constant, then I differentiate this one with respect to r. How is this going to be? This is going to be partial of second partial of v with respect to partial of r, partial of x, more like it's a mixed partial here, and that's going to be cos what? Cos theta. Remember I kept cos as a we kept cos constant. So what we do now is we'll keep this one as a constant, then we'll differentiate this one partially with respect to what? With respect to r. But observe, I have theta instead of r, so meaning this one here, all of it is a constant. So when you differentiate with respect to r, when you differentiate cos theta with respect to r here, you're going to get a 0. So I don't need to put it, because it's just going to be more like a partial of v with respect to r. When you keep it a constant, then you differentiate this one with respect to r, it's just going to be 0. So no need of considering it there, and that's going to be plus. Okay, then even this one, all the same, is going to be partial, second partial of v with respect to r partial of y there. That's going to be a mixed partial, and we have what? We're going to have a sine theta there like that, and that's how that one is unfolding slowly. Okay, so we are not yet done. So what it is here is that, for me to simplify work for myself, I'm going to write this as, so you observe to say what you have here. Okay, this is more like, instead of saying second partial of v with respect to partial of r, partial of x, this is more like you have partial of v, okay, divided by partial of r, partial of x, like that. But you know what your partial of v with respect to r is, so hence you can bring it here and say, okay, I have my partial of v with respect to r, and I'm going to put this into brackets. Then what is going to remain is partial of x, which is this one and this one here. Okay, so this step is very, very critical and very important. So this is going to be plus, um, you do the same here. When you break this one down, it's just going to be partial of v with respect to r there like that. Then what is going to remain is the fact that you're going to have your partial of y, then sine what? Sine theta. But remember, we earlier said our partial of v with respect to r, what we found was, we found partial of v with respect to x by cos theta, plus partial of v with respect to y, then sine what? Sine theta. So what we do here is just a matter of substituting. So where you have that, this is just going to be, um, I can bring it down here like that, which is this portion here. Then you still have this one, so we can place it there like that. Then we say plus. So now this one here is still the same one, which is this one, so I can just copy it down as well. Okay, like that. Okay, Then we still have this one outside. We have our partial of y, then sine what? Sine theta. So now what follows is just a matter of distributing what we have outside the brackets. So when you distribute what we have outside the brackets, this is going to be equals to, so this one by this one, you observe that it's a partial of v with respect to x by partial of x. That's going to be second partial of v with respect to x, like that. Okay, so observe between your partial of x, this can just be written as that there. Then you're going to have cos what? Cos squared theta, because that will be cos by cos. Then multiply this one by this one, and you're going to have a mixed partial. That's going to be plus second partial of v. Then you're going to have a partial of y, partial of x. This is going to be sine theta cos theta. When you apply this cos and that sine there, then you get to this one. So this is going to be plus, we multiply this one by this one, that's going to be a mixed partial. That's going to be second partial of v. Then that you're going to have a partial of y, partial of x. That's going to be sine theta cos theta. Okay, this is going to be plus, so this one multiplied by this one, that's going to be the second partial of v with respect to y there. Then that's going to be sine squared theta. Okay, so now you observe that this just goes down to, it just goes down to second partial of v with respect to x there. That's going to be cos squared theta, plus this is going to be 2 second partial of v. Then you have y, you have partial of x there, like that. Then you have your what? Your sine theta, and you have your cos theta there, plus this one here, which is partial of second partial of v with respect to y, then multiplied by sine squared theta. Okay, so we are done with this part here. Now let's try to determine what our second partial of v with respect to theta is going to be. We have already found what our second partial of v with respect to r. Okay, so keep this one in mind. I'm going to erase it because I have to use this space, but I've written it somewhere, so I'll just have to copy it afterwards when we are done. Okay, so you can get rid of that. That is the way it is. We'll try to bring it back afterwards. Okay, so now we are trying now to come up with the second partial. I mean, first of all, the partial of v with respect to theta. This is going to be equals to. So how this one is going to unfold is like this. Here, our partial of v with respect to theta is just going to be partial of v with respect to x by partial of x with respect to theta, plus partial of v with respect to y by partial of y with respect to theta. So now partial of x with respect to theta is simply equals to, if you differentiate this one here with respect to theta, that's just going to be minus r sine theta. If you come up with your partial of y with respect to theta, this is just going to be equals to r cos theta, like that. Okay, so now it's just a matter of substituting here. So we can have a partial of v with respect to theta being equals to, so on this part we're going to have minus partial of v with respect to x, and because this one is it's a minus r sine theta, so I've put this minus here, so I'm just going to put r sine theta there, then plus partial of v with respect to y, then our partial of y with respect to theta is going to be r cos theta, like that. Okay, so this is uh, our first partial derivative. Let's go ahead and find the second. So we can have it right there. So let's go ahead and find the second. So to find the second, we use the same steps that we use when you're finding the partial of v with respect to r. I mean the second partial of v with respect to r, where we say second partial of v with respect to theta are just going to be equals to, it will be partial of theta like that of what we have here. Okay, so I can bring it down here like that. Okay, let's go ahead and do the same thing that we did. This is just a product rule. So this is going to be equals to, um, I'll keep this one as a constant. First of all, I'll keep it as a constant. So how this is going to unfold is, if I keep this one as a constant, then I differentiate this one with respect to theta. This is going to be equals to minus second partial of v. Okay, second partial of v. Then I have partial of theta, partial of x. They are more like it's a mixed partial. Then what else are we going to have? Um, then you're going to have r sine theta. Okay, that's going to be plus. Then you are now going to keep this one as a constant, then differentiate this one with respect to what? With respect to theta. So if you differentiate this part with respect to theta, it's just going to be cos, but you're going to maintain the minus sign. Okay, so this one here, instead of positive, is going to be what? It's going to be minus. It's going to be equals to it's going to be equals to partial of v with respect to what? With respect to x, and that's going to be r cos theta. I've kept this one as a constant, it's still the negative there. Then I differentiate this with respect to theta, it's just going to be cos theta. Then that's going to be plus. So all the same here, you differentiate your partial, your second, that's going to be second partial of v. Then you're going to have a partial of theta, partial of y here. When you differentiate this one with respect to theta, then you keep this one as a constant, and this is just going to be r cos theta there like that. Then now maintain this one as a constant, then differentiate this one. This is just a product rule. Of course, differentiate with respect to theta, and that's just going to be minus r sine what? R sine theta. So that's going to be minus partial of v. Okay, partial of v with respect to y. Then I have r sine theta there like that. Okay, so now for this one and that one, I'm more like done. The only part that I have to do some simplification is this part and that part there, but I'll carry them along. Or what I'll do is that I'm going to preserve them somewhere. Let me try to copy them and or put them somewhere. So what I want you to keep in mind is the fact that within this we have this portion here, and I'm going to write it the way it is. I'm going to write it as, we have the minus partial of v with respect to x. Then we have let me try to squeeze it this side. We have minus partial of v with respect to x, then r cos theta. Then we have another one. That is minus partial of v with respect to y, then that will be r sine what? R sine theta. So keep in mind that we have these somewhere, but I'm just going to kind of like ignore that I have them for now, because they are more like they're already done. They're just waiting for the final stage where we decide to do some showing. So I can erase them there like that. Okay, we have our theta there like that. That's what we have. So now let me try to break this down just like we did in the previous one. So how this one is going to be is like this is going to be equals to, remember what I have here, I can simplify it for myself. Okay, and I think for convenience sake, let me start by using this one, then this one that has a minus, I put it on the other side. Can just do this. Okay, let me put it there. Can get rid of the equal sign. Okay, that is equals to that. So now this is equals to, remember this one here, just like we did in the previous one, we have our partial of v with respect to theta, hence I can like pull it out. Then that's going to be, we have um, here we say we have our partial of v with respect to theta. I've removed it from this one here. Okay, and um, what's going to remain is partial of y. Then you have your what, your r cos theta. Okay, that's what you're going to have here from this one. When I pull this one out, so it's like when you multiply this one and this one, you still get that one there. And that's a very simple step, that minus. Then I do the same here. So when you force it out, that's going to be partial of v, partial of theta there, and then you're going to have your partial of x, and that's r sine theta. Okay, so now going ahead with this one, this just turns out to be, so where we have this one, we can substitute with what you have here, that is our partial of v with respect to theta. So we can say open bracket, what do we have in our brackets? We have I'm going to start with a plus. Okay, I'm going to start with a plus. Of course it starts with a minus, but I'm just feeling like starting with a plus, which is this one. Then I write that one. Okay, that's going to be partial of v with respect to y. Then you have your r cos theta minus partial of v, partial of v here, with respect to x, that's r sine theta, sine theta, like that, multiply by what you have here, which is your partial of y. Then you have r cos theta. Then this is going to be minus. I'm going to copy this one the way it is. Okay, it's going to be here because that is what you're supposed to have at this point. Okay, this one is the one that I've put here, and of course I have to put it into brackets like that. Then this is multiplying what you have here, which is your partial of x, that's partial of x, and this is r sine theta. Of course this seems to be a bit long, but when you're doing it on paper without having to explain the way I'm explaining, when you're just answers are just flowing from your head, this will be much quicker. You can actually try it after we try it on your own after this is done. So what follows now is one of like the final steps. You just have to distribute this one inside the brackets as well as this one inside those brackets there. Okay, so multiplying this one by this one, this is just going to be um, second partial of v with respect to y there, like that. Then your r cos theta by r cos theta, that's going to be r squared cos squared theta. Okay, cos squared theta. Then minus, this is going to be uh, second partial of v. Then that's going to be a mixed partial, that's going to be partial of that's going to be partial of y, partial of x there, like that. And that's going to be r squared sine theta cos theta. Then this is going to be minus, because when I multiply this one by this one is positive, but by that negative there, it's going to be negative. That's going to be second partial of v. That's why I say that's also a mixed partial of y, partial of x. That's going to be r squared sine theta cos theta. Then you multiply this one by this one, it's going to be negative, but when multiplied by this negative outside, it's going to be positive. So that should be positive second partial of v with respect to x there. That's going to be r squared uh, sine squared theta, like that. Okay, so now one thing that you observe is that this just simplifies to um, this just simplifies to or maybe before I do that, it looks like I've already reached the final stage. Let me just bring back this one. I'll write this one, then I'll write this one down so that we see what is canceling out. Okay, so remember what we found was we said the second partial, if you remember, the second partial of v with respect to r there, what we found was something like was a second partial of v, okay, with respect to x there, like that, and that was cos squared theta. Okay, then we had plus, we had 2 second partial of v, that was a mixed partial. Then we have a partial of y, partial of x there. Then that was sine theta cos theta there, like that. Then we had the last term, that was the second partial of v, okay, with respect to y, then multiplied by sine squared theta. That's what we had. Then for this one here, okay, for that one, it's also pretty simple. If you say 1 over r multiplied by partial of v with respect to r is going to be equals to, so you know what your partial of v with respect to r is, I believe. So partial of v with respect to r is just equals to partial of v with respect to x, then here you have what, you have cos theta plus partial of v with respect to y, then here you have what, you have your sine theta. So if you multiply this by 1 over r, this just ends up to be partial of v with respect to x, then here you're going to have cos theta over r, okay, um, plus what, okay, plus your partial of v with respect to y, then that's sine theta over r, like that. Okay, that's what we have. Then now looking at this one here that we have down, if you simplify this one, you're just going to end up with something like we can write to say our second partial of, in fact this starts by saying 1 over r squared multiplied by second partial of v with respect to theta is equals to if you multiply the first term, because remember the first term, it was more like a partial of v, okay, it was partial of v with respect to y there, and it was like r squared cos squared theta. But if you multiply it by 1 over r squared, you observe to say your r squared goes, so it's just going to be cos squared theta. Okay, then the following term, the other term that was the other term that we didn't, I mean, the other term that we had was, it was more like a minus, because it was minus minus, so it's supposed to be minus 2. It's supposed to be minus 2 second partial of v, it's a mixed partial, partial of y, partial of x there, like that. Then it's supposed to be r squared sine theta cos theta, but because you're dividing by r squared, the r squared is going to go, so that's going to be sine theta cos theta there. Then that's going to be plus. Then the other term that we have, is supposed to be partial of second partial of v with respect to y, they are supposed to be r squared sine squared theta, but because we're dividing by r squared rather, that's r squared is going to go, so we have like partial of second partial of v with respect to y squared there, with respect to y, I mean, that's also going to be a sine squared theta. Then you have these terms, remember I said we have to bring them back at some point, so that's going to be minus partial of v with respect to x Okay, with respect to x, this is supposed to be r cos theta, but I'm multiplying by 1 over r square, so the r on the numerator is going to cancel out. That's going to be cos theta over r. That would be minus partial of v with respect to y. That's going to be sine theta over r when you multiply it by 1 over r squared. You multiply this one by 1 over r squared. Okay, so we can get rid of this part. So I believe we're able to see what is cancelling out here. So if you add this one, and this one thing that you observe is that this one is going to cancel out with this one. Okay, that one's going to cancel out with that one. Then this one will cancel out with this one. Then this will cancel out with that one there. So we're just going to remain with this portion here and that portion there. Okay, as well as here you remain with this part and this part. So let's see how this one breaks down if we add these terms that I've highlighted. In fact, I think for convenience's sake I can just erase um, this part. Okay, like that one has gone. We have cancelled them out. Okay, so even this middle part here goes. Okay, so one thing that you observe is that if you add this one plus this one plus that one thing that really stands out is the fact that you observe to say you first of all I'm going to have my second partial of v with respect to x squared. So you observe that I have another one. um, Actually this is x here, not y, sorry. This is going to be open bracket. We're going, it's like you factor it out. This is going to be cos squared theta plus this one plus sine squared theta, you close, then plus second partial of v with respect to y there, like that, open. You're going to have a sine squared theta, which is this one, then plus that one there, that's going to be plus cos squared theta. Of course, I believe we now all know where this one is going, and we know to say this portion here from trig identities, this is just one and this is just one, and this just simplifies to what, second partial of v with respect to x there, like that, plus second partial of v with respect to y, like that. So this is the same as what we have here, and we got it by using this one, hence we have shown, and that's simply how you go about that one. So once again, this seems to be a bit longer because I'm explaining. If it's an assessment, this is, you'll be much faster compared to me, because there will be no need of you explaining, of course, and everything's just going to be coming out. Yeah, so that's all in this video. Thank you very much for watching.